So go ahead and look at your formula chart. What does your lateral area of a cylinder say? Starts with 2. 2 pi r/h. And then let's go ahead and write out the surface area formula while we're at it. It's going to be the lateral plus how many area of the base? 2 pi r squared. So we know the radius is 8, and we also know the height is 11. So it looks like all we need is a radius and the height. We don't need to draw anything. So we have 2 pi, the radius is 8, height is 11. And I would do 8 times 11 is 88. What is double the 88?
176.
Very good, 176 pi feet squared. That's part 1. And I will copy that for the first part for the surface area, 176 pi. And we have 2 pi r squared. For the r squared, are y'all okay if I just write out 64? Yeah? Okay, someone double 64 for me. 128, very good. Pi. And because they both have a common term, I can go ahead and add them together and get 304. And it's pi feet squared. Okay, when you're ready, let's go on to number 5. Okay, Hannah, let's read number 5.
Find the lateral area and surface area of an equilateral triangular pyramid if each base edge is 8 centimeters and the slant height is 10 centimeters.
So for the pyramid, we have an equilateral triangular pyramid. So we need to start with the equilateral triangle formula. And it says each base edge is 8. That is one side of the triangle. So let's recall. The area formula was side squared and what? Root 3 over 4, and that's on your formula chart. So when I plug it in, we're plugging in 8 again. So I'm going to put 64, because 8 squared, root 3 over 4. And 64 divided by 4, how many is that? 16? So we have 16 root 3. So now look at your formula chart. What does the lateral area of a pyramid say? Starts with P? PL over 2. So we know the perimeter of the base is 8, 8, and 8. So how many would that give us? 24? And our lean is given slant height. That is our lean. 10 divided by 2. So we know 10 divided by 2 is 5. Actually, that's silly. 24 divided by 2 is 12. And then if I added 0 at the end, that's going to give me lateral area is 120 centimeters squared. So be clever about which one are we going to divide it by first. Now look at your formula chart again. For surface area, it says PL over 2 plus what? Capital B. That's area of the base. Did we find the area of the base right here? So we know PL over 2 is 120. We found the area of the base already, which is 16 root 3. Can I combine these two numbers? No, because one of them has a radical and the other one doesn't. Somebody's not paying attention, and I'm looking at him. I don't know. Okay. Okay, the next one was number 9, was it? Okay, for number 9, Blake, let's read.
Find the volume of the sphere and the radius of 3 pi inches.
Okay, so go to your formula chart, volume of a sphere. And it starts with 4. 4 pi r cubed over 3. So let's plug in what we know. All I need is my pi. Not pi, the radius. The only awkward thing is that the radius also has pi. So let's plug it in. We have 4 pi, 3 pi all cubed, all divided by 3. And let's take it step by step. If the cube goes to those two components, I'm going to keep the 4 pi as it is for now. What is 3 cubed? 27. And then if I have 3 of the pi's, I have pi cubed. all divided by 3. And then what I would do is take, what is 27 divided by 3? 9. What is 9 times 4? 36. So we're almost there. So we have 36. How many pies do I now have? 4. And it'll be inches cubed. Okay, number 10 is our last one. Okay, number 10, let's see, Spradley, go ahead and read.
Find the volume of a sphere whose surface area is 185 centimeters squared.
Okay, so we have to start with the surface area. So go ahead and look for a surface area of a sphere. It says for what? R squared. And we know the area is 180 pi. And write out 4 pi r squared. And then let's cross off the pi's on the left and the right. And then while we're at it, what is 180 divided by 4? 45. So we know r squared is equal to 45. And again, our quiz and test is simplified radical form and in terms of pi. So when I square root this, it's going to give us 9 and what? 5. So we know our radius must be perfect square of 3, radical 5. Now let's write out the volume again. We have 4 pi r cubed all over 3. And then we have 4 pi, we know our radius 3 radical 5. And the 3 radical 5 is going to be our biggest challenge on this problem. Okay, so then if I were to carry this over, 3 is going to go to that one and that one. So let's keep the 4 pi for now. And then let's also keep the 3 on the bottom for now. When I cube the 3, we get 27. Let's talk about cubing 5. If I have a radical 5 3 times, we have a set, correct? That comes out. But this radical 5 is not a set, so it goes back inside the radical. So let's start simplifying. What is 27 divided by 3? 9. And then I'm going to say, since 4 times 5 is 20, what is 9 times 20? 180. Radical 5. And we also had a pi, centimeters cubed. And that will be our final answer.